So in this course we'll talk about a vulnerability for command injection. So a command is you type in a terminal. So for example here in this screen it typed calculator and then it started the calculator application. It said echo test and it output echo test. So basically commands, and this is a command line interface here where you type a command and the computer does something. For example, we can open our own terminal. Let me enlarge it a bit. And here we can type commands, for example echo, which outputs anything to the screen, like an echo. And you'll see it returns that. Now we can start the program from here. So that's not installed. So we can start for programs, for example mousepad. This is a Linux computer, so on Windows that would be Notepad. So you can do commands, and when you type a command it returns output. So what is command injection? Is it related to this? Yes. The idea is that even a website, you try to inject a command. So you open a website and you manipulate the URL, the web link, to get internal access to the system to run commands. So in this course you will learn what this vulnerability is, and also will showcase it and the risk it imposes to your application, if it's your application. But if you're the hacker, then you can use it to gain access into the system. So we'll go over how to discover the vulnerability. So in any website, how you can discover it, how you can exploit it, you could prevent it. And so yeah, you can then abuse the system. So let's start with what is command injection. So command injection is the abuse of the app's behavior to execute commands on the system. So for example, if the website is running like some, in this case, website, an app, then you can manipulate the URL and try to inject your own commands. Command injection vulnerability also is known as a remote code execution, because what the attacker does, or the hacker does, is to trick the application into running commands. But this is without direct access to the machine itself. So the hacker doesn't do password attacks, but instead it tries to attack the application to run commands. So it doesn't need any passwords. It just uses the application for that. Now, especially if the website or the computer has multiple applications, there is a bigger risk that it has this vulnerability and that the hacker can just take over the system because it can run commands. Now, if the attacker can run commands, he can also open a shell into the system where he can then try to become administrator into the system. So in the previous video, we found out that we could do command injection in these web apps. So for example, in here it wants us to enter a domain name. We could say google.com, and then we can add a semicolon. And by typing the semicolon, we could add our own commands, and we could do this several times. So for example, pwd, who am I, and so on. So whatever commands can be, if it's a Linux server, it can be a Linux command. If it's a Windows server, it can be Windows commands. But using the semicolon, you can combine commands. So we click who is, and then when we scroll down, we saw the output. Now we could forward this whole junk output to a junk file. So we could say google.com forwarded to junk, semicolon, and then our commands. So That's what we could do. We also had another app where we could type an IP address or a web address, and it would show the output. After about 4 seconds or so, it would show us the output, and we could inject a command by using semicolon again. So semicolon, for example, who am I, or pwd, whatever commands. After 4 seconds or so, it gives us a reply. So it's a bit inconvenient to run commands this way, because we have to wait for the reply. We have to type it, and we don't see the command history. So it would be better if we could open a real shell, just like this one, and type our commands instead of doing that through that web interface. It's just not convenient. So we can create a so-called reverse shell. So in a normal shell, the idea is you connect to a server, to a computer, and run your commands. But with the reverse shell, the server connects to you and runs commands. So for this to work, you need to have an internet accessible computer, so publicly accessible. So run Kali on a VPS, run it in the cloud so that the server, your actual victim, can connect to your computer. But then instead of like connecting to the computer, to the server connects to you, to your public IP address, and then you can run commands on his or her computer. And this usually bypasses a firewall. So normally when you connect to a computer, they have a firewall that blocks your connection. But if that usually isn't the case for applications. For example, you might have a computer with all kind of apps on it, and it blocks incoming connections, but not outgoing connections. Like, they can surf the web just normally, right? You can start Firefox or Chrome and go browsing the web. You can download files, do Dropbox or whatever. So a reverse shell goes in the other direction. It connects to the attacker, and then whatever the attacker commands tells it to do, it executes. So it works in the opposite direction. So what if we could start a reverse shell? I have a course on reverse shells which goes much more into details on reverse shells, but what we want is, of course, to the victim, the server computer or the website, connects to our computer, and then we have a normal terminal where we can run commands instead of doing that through this chunky website. So you can find cheat sheets for reverse shells. So for example, the reverse shell cheat sheet and shows for all kind of commands how you can open a reverse shell. For example, Perl with Python, with PHP, OpenSSL. And there's multiple lists like that online. So basically what we need to do is to set up a listener. So I'm gonna open a new terminal and start listening on a port using a program called Netcat. So I'm gonna listen on port 4242. That listens for connections. And I know that our application can run PHP because in the website URL we have .php. So obviously this computer can run PHP. So we might have luck with this PHP command for reverse shell. There's also other ones here like Bash, Perl, Python, Ruby, Netcat. So which work will really depend on whether any of that is installed in the computer. For example, if the website doesn't have PHP installed, obviously this attack won't work, and you might need another like Node.js or Python or Bash. So we're gonna copy this command, and with the command, with any reverse shell command, it always needs to connect to something, which is your computer, so, and your port. So we define a port here, 4242, and we're gonna change the IP address to our own IP address. So that should be your public IP address. If you're on the same network, you can use your network address. So I'm on the same network. I will do my network address, IP address show. This is my IP address show command, shows you your computer's IP address. So it needs to connect to this IP address. change this command to 192 to your IP. And the port is the port we defined before. So we wanted it before to listen to 4242. So we need to change that as well. Now it will do some stuff here, but we can just copy it. It's the command we need, and we're gonna reduce the size here. So that's the malicious payload. We don't need to save it. I copied it. So inside whois, we could type a domain name, and then it run the whois command, and we'll do a semicolon and then paste that command. So semicolon, paste the command, and click whois, and you'll see it opened a shell here on the right. So we have a reverse shell now, and now we can type commands just as normally without any delay. So now we're inside the system. So we can change the directory. We can browse around, for example, into the home directory, directory, or whatever files they have, right? etc directory. We now have access into the computer. So we have a reverse shell. One thing to note is that we are not root. We are not administrator of the system. On any Linux system, root is the administrator of the system. So here we are just a regular user. We are not administrator root. So what hackers will try to do next is to become root into the system, or just to browse around the file system and see if there's anything interesting. So we started a reverse shell using the command we found in the cheat sheet. We took the Python one, and one thing to keep in mind is that we also started a listener. So we typed netcat -lvp, so that listens verbose to the port 4242. So we can start a listener. Let's see if we can use any of the others. So bash is almost always installed in Linux, so let's try that one and see if that works. We're gonna change the IP to our IP address. Let's see if I can enlarge this font. Okay, so this was the command before, and we will change that to our IP address. So the number here, 10.0.0.1. So we change that to our IP address. And you'll see port here 828080. That's not the port we chose. We chose 4242. You can pick any port you want. So I just chose 4242 as a random. So we're gonna copy that command and see if we can use the bash shell to create a reverse shell, or the bash program. And pick any of these websites, google.com, semicolon, and we're gonna paste it in. Click whois. And you see that one didn't work. So sometimes the reverse shell, you have to try around, fiddle around a bit. For us it worked with PHP, but it didn't work with the bash one. So it really depends on what is installed, and also if any of those programs are cured. So you'll see Java here, Ruby, PHP, Python. It really depends on what is installed in the system. So for us, the PHP command worked. So we would copy that command, change it to our IP address, change the port. Now here we set up the listener, netcat. Then in any of these apps, it doesn't really matter because both are vulnerable to this. We say google.com, semicolon, and paste that command. Click go. and that should pop as a reverse shell. So here we go, you see the $sign here. So we can run commands, and keep in mind that what's happening actually is that the client is not connecting to the website, but the website is connecting to us. That's why the website keeps loading, because the website is connected to our computer. And in order for it to connect, you need to have your computer publicly accessible on the internet. So you need to have Kali running in the cloud or on a VPS, because then you can connect to the computer. If you're on the same network, you can use the network IP address, but if you're on the internet, the public internet, you need to have a public address. So you need to run Kali in the cloud for it to work then. But basically, we have a reverse shell, which works exactly as a normal shell. So we can type commands, browse around the system, right? We might enter etc. We might output the password file, try to output the shadow file. You'll see now it says permission denied. So what a hacker will then usually try to do is to try and become root to administrator, which can do anything on the system. But basically we got access into the system, right? We have user level access now because we could inject our own commands and gave us access, which gave us a shell, a reverse shell. So the first thing to do is to discover if the web application is vulnerable to command execution. So many programming languages, you can create this vulnerability in many programming languages like PHP programming, Python, Node.js. It doesn't really matter how they made the web application, as long as it's running commands. Now, an application on the web usually is a black box, meaning you don't have access to the code. Opposed to other applications might be white box. So that means that you know what the code is doing. For example, if it's running a popular blogging software like WordPress, Drupal, or something like that. So it can either be black box or white box. If it's black box, you have no idea what the software is actually doing internally. If it's white box, you can take a look at the code. However, in both scenarios, the vulnerability could be there. So just because they don't give you the code doesn't mean that their application is secure. So, for example, it could be that you have an input. So in this case, there is an input text field where it says enter an IP address. So they enter an IP address and it results in the command output. But on top of that, they add here another command, who am I, which in Linux you can combine commands using the ampersand. And so now it's running another command that instead of just the IP address. So in this case, they can run commands on the system. So it works in this case by manipulating the input text fields. In other scenarios, it can also be done using the URL. So sometimes it might be that it has a slash something, for example, a file name, and then you can add commands in the same way. So we'll demo that later on. So how does this injection work? Well, in the code, they call a function, for example, shell exec in PHP or system, that runs a command on the system. So they might have real reasons for running the commands. For example, the example before, they wanted to show the output of the ping command. So they will do shell exec ping. You'll see here, if I zoom in, it's running shell execute, so it makes the system execute a command, and in their case it would be ping instead of NSLOOKUP with the URL or the IP address that is an input, right? So this is the PHP. So if you have access to the code, you can search for shell exec or system, and this function, it runs it runs code on the system. So if I search for shell exec, you'll see the PHP page. So execute a command via the shell and return the output. So they do that in web applications, sometimes because they want to give output of the system command, but they only wanted to run that command. And the idea is, of course, to run then any command, so here they injected that. So shell exec is the function in PHP that does that. For example, here they run shell exec function with the list command. They store the output in the variable output. So $sign in PHP is the, let me zoom in. So $sign, where is it? $sign, this is where the output gets stored, and then it gets output to the screen. Now in this case, it wouldn't be able to be manipulated because it doesn't add any variable here. So if we take a look at the other code, you'll see there's a variable here, $sign URL. That means that if we can manipulate the variable, then we can take over the system. It can also be that it's in the URL, so then it would just get the URL variable, in this case name, and then you would be able to inject commands from there. So there's different ways that it can be manipulated, but the main idea is to inject your own commands, given that they already execute commands. So given they already run the shell exec function, if it's a PHP application, is that you inject your own command after the normal command. So in this scenario it wouldn't be possible, but it would be possible if they, for example, add another variable. So if they would say like some commands that they get from the input, right? So if they get an input command, so it can be a text field, can be a URL, then you could be able to insert your own command into the shell exec function. So that's the main idea of how it works. So for PHP, it's shell exec. It can also be in Python. So if they have a Python code, there's a similar function that has the same behavior, and that function is called execute commands. So if I search for that, execute commands, so that's a similar function. So that's okay, all this stuff about cookie. That is a similar function or subprocess runs a command on the system. Yes, and so you can do it with subprocess. And also there's a command way to run this, so command.run. So there's different ways to run it. .system runs commands as well. So it doesn't really matter if the code is in Python, in PHP, in Node.js, as long as there is a variable in here. So not hard-coded one, but one that is given from the input. So the idea is to manipulate the input, which can be a text field or a web URL, and then try to inject it, as is done in this example where they inject another command. So if you are a programmer, you often look at code. So we could take a look at this code. You'll see there's a lot of web code here. So all of this is web code, HTML, which just displays what's on the screen. And this is the actual PHP code. So you'll see question PHP all the way down here to question /. So this is the actual programming language code. Top is just the front end, so the code to show the website. Now, if a website is vulnerable or any application is using to this kind of attack, there are several functions that are interesting. Those functions are shell_exec that will run a command. Then there's some other functions. So for PHP, that is shell exec. just exit, pass-through, and system. So all of these functions function in the programming language. When it's called, it always has those braces. So those functions might be vulnerable to command injection if the attacker can inject their own code in there. So when we looked at the ping command, you'll see it does shell exec. It calls the function with the ping command. So this is what it does in the terminal with your input. Now, in this case, to prevent the attack, what you will do is to make sure that this input is not allowed to this input is not allowed to be different than 4 numbers or a website URL. So, for example, we could check if there is a semicolon in the input. If there is a semicolon in the input, that means that the attacker is trying to add a second command or a third command. So you could check if there is a semicolon in there and try to stop that. You can check, in this case, this is the ping command. So we can check if there is a dot in the input. If you want only to allow internet addresses, you can check if all of it is numbers or dots. You could check if it contains any commonly used commands. So does the input contain who am I or sudo or any of those commands? And that will then try to filter that. So what you want to do is to filter the input. So this is for PHP and PHP code specifically, but for Python and other programming language, you also have functions that directly run commands on the system, and then you have the same problem. So the input in those functions need to be filtered. You need to be sure that there can only be certain characters and other characters are not allowed, right? So semicolon shouldn't be allowed because we don't want the user to eject. There shouldn't be an ampersand or a slash, for example. So you can filter inputs to stop that. Now, one thing to keep in mind is JavaScript is very popular these days, but JavaScript works just on the client side. So people can disable the JavaScript and then it would bypass your filter. So you want to do the filtering. You want to check the input on the server side. So in this case in PHP code, to prevent this kind of attacks. So let's do a practical. We will install a website on a computer. So let me just remove this one. You can have a second computer where you install Ubuntu Linux from ubuntu.com, or you can do it in VirtualBox. VirtualBox is a program that lets you run multiple systems in one computer. So depending on if you have another computer left over, you can turn that into a web server. Or you could run one online, so a VPS or a cloud. You need Ubuntu access for your website. So I'm gonna use VirtualBox and click New and type Ubuntu web server. Next. Now adding some memory. I will run it from memory, so I won't actually install it onto the computer because this is just a demo, but you might want to install it onto your computer, onto the virtual computer, I should say. So I'm gonna click settings because we need to configure it. And the first thing we'll do is go to network and select bridged adapter. When you select bridge adapter, the virtual computer is on the same network as your other virtual computer. So select bridged adapter. And then we're gonna go to storage and we're gonna enter the installation CD of Ubuntu. So Ubuntu desktop, I will just load that one, live CD, click OK, and I'm gonna click start. So that will start the Ubuntu setup, and you see we can run Ubuntu from memory as well. Which is what I'll do. I will skip the installation to save you some time. But if you want, you can install Ubuntu on your virtual computer or on your second computer and follow the same steps, because there's not too much difference between the virtual computer, the virtual, running it from memory and to install it, as far as the hacking is concerned. So it might take a moment to start the virtual computer, to start the setup, depending also how much memory you give it. So maybe I gave it too little because it's taking quite a while. Let me change that. So I'm gonna power off, go to settings, system, memory. Okay, maybe it should have a little less. Okay, start. So try. And that should start the Ubuntu system. So you'll see it's loading. And we'll set up the server. So you can do the same steps on a second computer if you buy a Ubuntu CD online and install it in your second computer, or you can create a CD yourself, the installation CD. If you head over to ubuntu.com, you can find the system. So I'm gonna skip the installation, because what I'll do is to run it from memory just to save some time. So it will pop up with some installation screen that I'll close. So I'm gonna close this screen. Yeah, quit. So, sorry, I pressed the wrong button. Okay, now I have to restart again. That's a bit unfortunate. So I'm gonna start the Ubuntu and then click try. That will run it from memory. And that way we'll be able to run all the commands for the installation, but we don't actually have to go through the install process, which takes some time. So setting up is gonna take a little bit of time, but then we will be able to hack it in a real scenario instead of just videos. So as you saw, this is gonna take a moment to run the setup, but then make sure to click try and don't press the close button. So it's gonna come with that pop-up in a moment, and I'll click try. So try Ubuntu, press that one, and you'll see it then runs Ubuntu from memory. Now, obviously you can install Ubuntu to your computer if you want to do that. If you have a second computer, you can install that, or even inside VirtualBox. But I'm gonna skip that, because as far as this example is concerned, we just need a Ubuntu computer. We don't really need to fully install it. So I'm gonna open a terminal. I clicked here and then terminal, or type terminal on top here and start it. We'll enlarge the font because it's barely readable. Okay, where is the font size? So it doesn't let me change the font here, custom fonts. So the next thing to do is to start Kali Linux. You can either, if you have physical computers, you can get a USB with Kali installed and plug it into your computer to start Kali Linux. If you're using VirtualBox, you need to follow the same steps again. So inside VirtualBox, if you have the VirtualBox screen, you would need to click New and then go through the steps with Kali. go to settings, go to network, select bridged adapter to be on the same network, and then click storage, insert your Kali Linux CD. You can get it from Kali website, Kali Linux website. Insert it, click live CD, and it will start. And this is what you'll see. So depending on whether you're using VirtualBox for this or whether you're using a real computer. So if you have a real computer, of course you would get the Kali that you can just, or Kali Live USB, which you can buy online. So you'll see I have the IP address here, and I got that using the command IP space adder show. So that shows the IP address of your computer. So IP adder show, and you'll see this is the address here. So I can type that address into the browser on Kali, and you'll see I can type any domain name here. This is the website. So this is the website running on this web server here, and I can type google.com, for example, click whois, and you'll see we get it runs whois, gives you the whois command information. So now we would be able to inject a command using a semicolon. So we could say google.com semicolon pwd, and click whois, and it shows the output here on the bottom. Now I don't want to see all this information, so I'm gonna type google.com forward it to junk semicolon pwd. I'm gonna copy it just to save some time. Whois, so now we just get that output. I type who am I to see which user I am. So I'm the user www-data. So next we might want to start a reverse shell, because typing commands like this is very inconvenient. So we can search for reverse shell, cheat sheet. Yeah. I'm gonna open some links so we can see different cheat sheets here. We're interested in PHP. There's different programs that we might use for reverse shell. I'm gonna select PHP here. Might try the top one, and obviously we need to first copy it to Notepad, and this needs to be our IP address and port. So I'm gonna open another terminal and type IP adder show. You see we are on the same network, so I can use my network IP. So this IP, copy that, and I'm gonna paste it in. Now the port here is 4242, so I need to start a listener. Netcat minus listen verbose port 4242. Could enlarge this maybe. Okay, so I'm running this command to start a listener for Netcat. So this will start a listener. So here we go, it started a listener. And we run this command on the computer. So this will start a reverse shell. What it will do is the website's computer will connect to our computer on this port and then run the shell. And anything we type then in our shell will be executed on the server computer. So it's a reverse shell, this line of code. So I'm gonna copy that. And in here, instead of who am I, I'm gonna paste that code. And I want to see the reverse shell window at the same time. So let me just full screen then. So I pasted it in here, semicolon with the commands, and click whois. And you'll see now we have shell access, so we can type pwd ls We are inside the system probably. I can type cat etc issue to check the system version, and you'll see it says Ubuntu. So we have shell access into the Ubuntu system. I am running Kali Linux. So as you saw, we set up Kali Linux. So we are inside the system now. We might take a look at etc first. So we see that there is the users here, for example, anything higher than 9,999 are users in the system. So there is a system Ubuntu. There is a system user called root on top. Every Linux system has a root user, that's the administrator. We might want to know the actual passwords, which are stored in the file etc shadow. So if we try to output that, we get a permission denied. Maybe we can run some commands as root, or maybe we can become root to the administrator of the system, right? We want to have full access into the system and not user level. So we can type sudo -l, and you'll see password is required in the system. So the next step that a hacker will do is to try privilege escalation. I have a course on that, Linux privilege escalation, where you will learn different techniques on how to become root in the Linux system once you gain initial access, like here. So we have access into the system, we can browse around. For example, we might enter the home directory, you'll see the Ubuntu directory. In this case, it's owned by Ubuntu, so we can't look into that, but we can access etc directory. We might access the log directory and see system logs. So we have a shell access into the system. You'll see that it keeps loading. So that is because it's doing a reverse shell. It will only disconnect once I disconnect from this shell. So anything I type here is not executed on my own computer, but is executed on the computer on the right here. So you'll see he doesn't notice anything here. Everything looks normal, but we have control over this computer at the user level. So if I type who am I, you'll see I'm user www-data, which is a regular user. If I type groups, you can see the groups you're a member of, so I'm only member of the group www-data in this case.